So I welcome you to Module 4 entitled Physical Layer. In this module, we are to tackle all about physical layer, its characteristics. One component that falls under this layer are our cables. We'll tackle details on our cables, twisted pair, coaxial, fiber optic, and aside from our cable, wireless also falls under this layer. Okay. So again, main purpose of this layer is to provide the physical connection to our end devices, and that is our cable, if it's wired or wireless, no? So, uh, basically, we can obviously we consider there's always a physical connection, whether if it's at home or in office or in an enterprise or even in telco. Okay. Use the specific component in our laptop or computer that connects our cables is the LAN card. Our computer or laptop nowadays usually has two LAN cards. One is for the wire, the other one is for the wireless. Or it may have, it may even have, there are even um, computers that has, say, two LAN cards or more. Okay, two wired LAN cards or two wireless LAN cards or more for whatever purposes there is. Okay. Um, in terms of uh, our cables, they differ on in their characteristics and in their performance. So that's our agenda. That's what we are to find out in this discussion. One concept behind the physical layer is it transmits bits. Bits are um, ones and zeros. No? So there is this ones and zeros that flows through our cables. Literally, it's not ones and zeros. No, ones and zeros are representation of the nature of the signal that flows through our cable. Technically, like it represents the current flow. Okay, so so again, there's these ones and zeros. No, the signal that transmits to our cables, and the first component that receives this in our end devices. Let's say um, in this side of our web client, say there's a data that flows from the server going to the web client. So again, there are ones and zeros, okay, streams of ones and zeros. These are our data. So the moment that the web client receives this, the specific component that receives that is the LAN card. Okay, so the LAN card, as we mentioned in module 3, it is a component of the data link layer. What it will do is to encode. Okay, we will discuss later what encoding is. Okay, and then after encoding, okay, uh, it will undergo that process of encapsulation. Okay, if it's transmitting, no, like in this case, the web client will receive that, so it will undergo the process of de-encapsulation. It will read, uh, like for the LAN card, the MAC address, okay, and then goes up to the different layers in the OSI. So let's look into some of the physical layer characteristics. Uh, Physical layer standards are governed by these organizations. Okay. Later we will discuss one standards developed by EIA-TIA. Okay, the way to create a straight through, a crossover, and a rollover. So that's one standard. So it's the one who come up with that standard is this EIA-TIA organization. Some organizations include those that are in this list. When we talk about standards, specifically in the physical layer, it composed of the components. It lists down components. Example, if you were to manufacture twisted pair cable, okay, it lists down the materials to be used, specific wires to be used, the length, the diameter, the conductivity of the material, very detailed. Okay, you will see that in the standard. IEEE has that. During our live session, we'll look into this. Um, those acceptable encoding and signaling method uh, that a manufacturer may look into if they were to come up, if they were to manufacture a cable in this case. So there again in the component it includes the devices, hardware, okay, the media, and then I say the type of connector. In the encoding, it converts the stream of bits into a format recognizable by the next device in the path. It is in the encoding where the LAN card will interpret the 0 and the 1s. There are different encoding mechanisms. It is discussed in your computer organization and architecture. Okay. Um, like for example, Manchester. This diagram here is Manchester. Like in the Manchester, away 0 is interpreted, away 0 and 1s are interpreted, is the Manchester encoding will read the signal at the middle of each bit period. Okay, that is if there is a falling voltage or a drop in the voltage, okay, like this one, there is a drop here, okay, or from high to low, that's what we mean by drop, it will be interpreted as 0. And if there is a rising voltage, so if there is a uh, an increase in the signal from low to high, it will be interpreted as a 1. Okay, so in this discussion, very important that you are well aware of the term encoding. Okay, different encoding techniques is beyond our scope. It is usually discussed in detail for students who are taking electronics engineering courses. In the signaling, okay, in the signaling method, which is then again processed in the LAN card, this is how the bits, values, and ones are represented in the physical medium. If you look, we usually see this form and we say this is the digital signal. Okay, but you know what? In reality, there's that what there's this device we call as an oscilloscope. That is where you can see the actual signal. It doesn't look like this. Okay, this is not the ideal. This is the ideal scenario. Okay, usually it looks like, say for example, like similar to this one. So how can we say that a specific part or chunk here is a 1 or as a 0? So there are signaling technique. Okay. In electronics engineering, they apply mathematical technique for that. Again, that is beyond our scope. Okay. Very important that you are well aware of how to define signaling. Okay. Um, there, okay. Take note also that in our computer, our computer can process audio signal, okay, and usually audio signal are in this form. And take note that our computer is in digital, like in this form, okay. So also in the signaling is how are these being interpreted? That's the idea about signaling. And like in electronics engineering, they are taught of this modulation technique, AM, FM, PM. Amplitude modulation, frequency modulation, and then the phase modulation. That is beyond our scope. In electronics engineering, that's already a one course. Okay, but at least in here, you are well aware of the term modulation. Bandwidth, okay. Bandwidth defines the rate of transmission, the rate of data transfer, how many bits of information can be transmitted in 1 second. That is how we define bandwidth. Okay. Very important in the bandwidth is the unit of measurement. It is expressed in bits per second. There is a bandwidth specification in our cables. So as with our LAN card, specifically on the port of the LAN card, We also have bandwidth specifications in our um, ports in the switch and in the router. Okay. So again, rate of data transfer, we call it as a bandwidth. Then we have some terms also here. Latency. Latency is the propagation delay or the time of travel, okay, from one point to another. Okay. So for example, let's say I have two computers here, A and B. Okay. A will send data to B. Okay. Uh, the time to the time that the data, say this one, reaches B, example, it reaches the data to be sent at around, say, 5 milliseconds. Okay, so this is what we call as the propagation delay. Okay, there. That is based on the definition. There are other definitions for propagation delay, back and forth. Okay, let's say for example, A sends data to B and then acknowledges the receipt of the data. And let's say the time from A to B and then from the acknowledgement of the data, B to A, it reaches like around 10 milliseconds. Okay, uh, that is also another definition, an acceptable definition of latency. Okay. Throughput is the actual speed. When we talk about throughput, this is the actual speed. We know that, let's say, example with internet, uh, we subscribe to a 5 Mbps a subscription plan. That's the bandwidth that's the bandwidth of our plan, of our internet plan, DSL plan, for example. We do know we usually complain with that. It's not 5 Mbps. Sometimes it's only 500 kbps or 1 Mbps at this time or most of the time. So that actual speed that we measure, the right term for that is throughput. Okay, so the measure of transfer of bits at that period of time, we call that as throughput. We say we define good put as the measure of the usable data, okay, transferred for a period of time. Take note that this data here that I sent, say from A to B, aside from the data, there are other informations. There's that what we call as header, okay, or overhead. These are informations added on our data. So if we were to talk about just the data to be transmitted from A to B, by concept, that is of course by concept, ano, it cannot be reliable without the added information. But by concept, we call that as a good put. So now let's look into some characteristics of our cabling. Um, in copper cabling, there are two cables being used. That is twisted pair, okay, twisted pair, and the other one is coaxial, coax, okay. The most commonly used type of cabling is this copper cabling, specifically the twisted pair, especially the twisted pair, because they are easy to install and cheap. Okay, actually there are only two cables being used: the copper cabling and the fiber optic. Okay, so the twisted pair is the most commonly used and easy to install. Uh, Problems with copper cabling is it encounters interference. Okay. The way we define interference, these are or noise. These are unwanted signals that transmits to our cables and which causes errors. Errors is like the LAN card may, instead of, let's say, the right bit is 1 and it may be interpreted as 0. And the reason why there's wrong interpretation is because of the noise and interference. Okay, this noise and interference came from um, electrical appliance that is so near to our cables or to our computers or end device network devices, It may distort or corrupt our data signals. There are different types of noise or interference, okay? But these two are sorry, these three are the most important when we refer to computer networks. So we have EMI. EMI usually these types of interference um, came from those appliances, say, that has motors. Okay, example, microwave oven, if it's too near to to a server, okay, or an electric fan, okay, or ref there. Radio frequency is interference originating to our wireless device, cell phone, TV, radio, and then crosstalk is a noise coming from its adjacent wires. Okay, so let's say if I have these wires here, say I have two wires, and say this wire, the this one, say this is for the transmit, say from left to right, the other one is say for the receive, uh, right to left. So the noise coming from one interferes to the so the data transmitting through this cable 1 or wire 1, it is interfering to the data or signal being transmitted in wire 2. So we call that as crosstalk. Another issue with cables is this term we call as attenuation. Okay? In attenuation, we call that as the weakening of signal strength. If we use cables, there's this maximum distance we need to consider. So for example, if I were to connect A to B, and say if I were to use twisted pair, there's this maximum distance we need to consider. And for twisted pair, that is 100 meters. So let's say you overlook this rule. So let's say the distance of A to B is 150 and you use a twisted pair that has a length of 150 meters. What will happen is that the signal will encounter attenuation. It's like like in our phone, that's 1 bar, di ba? Low signal, ganun. So expected what may occur is like a signal in our computer na nag on off, ganun. Or worse, no connection. Okay? So to adhere this issue, we have to consider yung mga maximum distance to ensure that there is less interference. Better to provide proper shielding, okay, proper shielding. And just like us, cables also has social distancing. Now we have social distancing, but with cables, they observe even from time, even before that they observe ample distance. There should be an ample distance. Okay, what I mean by ample distance, for example, if you look into electrical standards, say if you have this group of network cables in the ceiling, it should not be near. Okay, there is this ample distance in meters with the network cable pipe to the electrical with the network cables, group of network cables, and then to our electrical cables, so as not this helps to lessen the interference. Okay, with crosstalk, uh, the to resolve issues on crosstalk, like with twisted pair, the main reason why those wires are twisted is to reduce crosstalk. Okay, so these are the types of copper cabling, and then again, as I mentioned a while ago, we have twisted pair and then coaxial. So in the twisted pair, uh, characteristics is that there are 8 wires and they are being paired. So there is a pair here that is used for transmit. There is also a pair for receive. Um, I will send you a copy of the straight through, a way to create the straight through and crossover cable. That is where you can see specifics for the specific pairs that are for transmit and receive. If you notice, there are colors here. Those are standards designed by EATIA. Okay, we do not see any colors out there aside from this orange, green, blue, and brown. Okay, because that is a standard. Okay, so regardless of the vendor or manufacturer of the cable, okay, these are the colors that you expect. Okay. Again, these wires are twisted, and yes, you are correct. As I mentioned, the main reason why these are twisted is because um, to reduce, and that is used to reduce crosstalk. Twisted pair has two types, no? UTP and STP. In other books, there's three mentioned. UTP, unshielded twisted pair. The shielded twisted pair, and there's what we also call as a hybrid. Okay? But in the module, it only mentioned two. The connector used in twisted pair is RJ45. RJ means registered jack. There is an outer jacket. This is to protect the wires from interference. It serves as an insulation. Okay. And then there's the STP. In the STP, it differs to UTP. First, because it has this braided shield. This braided shield is a protection from EMI, additional protection from EMI and RFI. Okay, aside from the outer shield. Another is each pair it has a cover. Okay, a cover. So with STP, it has a much better protection compared to UTP, but expect it is more expensive and harder to terminate. Okay, just like with UTP, its connector is RJ45, and again, as I mentioned, very important that the maximum distance of this twisted pair, both UTP and STP, is 100 meters. The color coding again is standard, so meaning you expect for UTP and STP, you expect they have same color codings. So as for the coaxial, it consists of a copper conductor. This is where data is being transmitted, and then a protection from the data from noise, interference, EMI, RFI are these other parts, no? Like you have this plastic insulation here, and then the braided shield. By the way, the use of the braided shield, it's a conductive material. This is the one that absorbs noise and interference. Okay, so as the noise and interference will not pass through our copper conductor here. And then we have the outer jacket. We usually see coaxial cables in cable TV, right? If you have Sky cable at home or Signal, even Signal, the specific connection, like for example in the Signal, I have a Signal here at home. The TV going to the satellite dish or the antenna, the specific the specific cable used is a coaxial cable. We have two types of coaxial cable, a thin coaxial and a thick coaxial. Uh, Another maximum distance for coaxial cable is 200 to 500 meters. Okay, much longer as compared to a twisted pair. Okay, uh, from the looks of this diagram, it seems that coaxial has a much better protection from EMI RFI as compared to a twisted pair. Okay, but um, others say it's much still twisted pair is the easiest easiest type of cable to in terms of the installation. Okay, there. But as I observe, example when I saw the technician terminated coaxial cable here in at home for the signal installation, I don't see termination for coaxial difficult. Okay. Anyways, with connectors for coaxial cable, so we have BNC, N type, and F type. So this ends part 1 of module 4. Keep safe. Together we learn as one.